All right, here is your final exam review. So this one, you're doing the empirical rule. I know that because it says like 68.95, 99.7 right here. I guess it says use the empirical rule down there in the instructions too. The mean goes in the middle, so 170.5. And then what you do is you start adding the standard deviation to get to the next blank. So I do 170.5 plus 19.9, and then I have 190.4. That looks like it would go right here because that's between 180 and 200, okay? You may have to add it one time, two times, or three times to get there. I only added it one time, so that means I'm one standard deviation away. And then for the other side, I'm going to subtract 19.9, and I only subtract it once, and it looks like 150.6 goes right here because that's between 140 and 160. So I added it once and I subtracted it once to get to those two blanks. So that would be 68%. If I had to add it twice or add it three times, then twice it'd be 95, three times it'd be 99.7. All right, next one is a z-score. The z-score formula is the data value that you're looking at minus the mean divided by the standard deviation. So here I'm comparing to Ryan's score and Joe's score. Okay, so Ryan scored a 580 and Joe scored a 495. For the physics test, the mean was 639 of 22, okay? And then Joe took the math test, okay? So what I do for this is I'm gonna hit the fraction bar to make a division symbol right here. For Ryan's score, he took the physics test, so I do his score minus the mean, 639, divided by the standard deviation. So his score is negative 2.68. Okay, let's clear that. Now I do Joe's score on the math test. Joe scored again, I'm going to hit the division sign to get the fraction up there. 495 minus the mean for the math test divided by the standard deviation. So as always, your data value minus the mean divided by the standard deviation. And I get negative 2.11. Okay. So one thing to note on here is it says right here that this is clearly skewed. If it said it was clearly skewed, that means we cannot compare their z-scores. So the answer to part B is actually it is unclear because it is clearly skewed. If it said they're normally or approximately normal, then I could compare those z-scores. And Joe's score is a little closer to the average because it's negative 2.1, which is a little closer to 0, than Ryan's score of negative 2.68. But since it says clearly skewed, my answer is it is unclear. We cannot compare the z-scores when it is skewed. All right, so another empirical formula one. We got 830 for our average, our mean, and our standard deviation is 90. So 830... I know it's empirical formula. Does it say empirical formula anyway? No, it doesn't say empirical rule anywhere, but I know as soon as I click that drop down, when I see that 68, 95, 99.7, that has something to do with the empirical rule, which means I need to add and subtract the standard deviation from the mean. So it says the batteries have lifetimes between 560 and 1100. So I need to add 830 plus 90 until I get to 1100. So I add it once, I add it twice. Let me see what I get there. I add it three times. So I added it three times. So that means I do 68 for 1, 95 for 2, and 99.7 for 3. That 75 is just something to throw you off. You'll never use that. Okay? So I'm going to assume it's 99.7 because I added 93 times. To check it, I can subtract 90. If I subtract 93 times, I should get that 560. Okay? So if you add it once, it's 68. If you add it twice, it's 95. If you add it three times, it's 99.7. Okay. To figure out approximately 68%, that means I'm just going to add it once. I'll show you a trick here. Doesn't save you that much time, but you can hit this plus or minus button right here, and that will add or subtract it all at one time. So I add it once and I subtract it once, and I get my two numbers right here, 740 and 920. All right, on the next one, I'm just finding the z-score. Is that all I'm doing? Find the z-score, the number of physics relative to the number. Okay, well, that should be a lot easier than that number 2 we did. So the z-score, again, I'm going to hit the division symbol. Trey caught 44 fish, but the average caught was 27. Divided by the standard deviation is, oops, didn't mean to hit that, is 7. So your data value minus the mean divided by the standard deviation. That might be one formula you got to memorize during the test. What's it say to round to? Round your answer to 2.42857. 2 decimal places. 2.49 was it? 2.43. Okay. So that one you just got to find the z-score. You don't have to do anything with it. The next one, again, we're finding the z-score, so you're going to use that formula a lot. That's why you might as well just memorize it. I'm going to hit the division symbol. It's your data value minus the mean divided by the standard deviation. So on this one, the data value is 26. The mean is 15 divided by the standard deviation, which is 9. So Deshaun's is 1.22. So fill in this blank. Deshaun's commute distance is 1.22. It is positive, so it's going to be above the mean. Okay, if it was negative, it would be below the mean, but it's positive, so we go above the mean. Positive above, negative below. I don't think I probably meant to put this problem on here twice, to tell you the truth. Well, that's fine. I guess should be easy points if you put it on here twice. So this is the same one as number 2. I'm not going to change it now because y'all are already taking the test. So, okay. So Lisa scored 683 points, and the average for her camp, where's that at? Last season, the total points scored in the summertime. And Lisa was in the summertime. So 514 divided by 70. Again, your data value minus the mean divided by the standard deviation. 2.41. And then I do the other one. The other one for Layla is Layla scored 338 minus the mean at Shoreline. The Shoreline mean was 437 divided by the standard deviation 64, negative 1.54. So these are pretty far apart, or 4.55, I guess. So now I'm going to go back and look. Is it bell-shaped? Yes, or approximately normal, which does mean the same thing. It is clearly bell-shaped, so I can compare them. So based on which one had the best, who was the lower scorer? The lower scorer would have been Layla because she is below average because it's negative, and Lisa is above average. So you got like 4 problems right there with the z-score. Okay. You will need that z-score formula here as well. This is a normal distribution problem because it says an individual with a score of 45 or less. Okay, so what I'm going to do here is, since I'm trying to figure out what proportion of people, I'm going to use this button right here, the PZ of less than or equal to. Okay, and it's talking about my Z being less than or equal to, so I put the z-score in. I'm doing 45 or less. So 45 minus the mean is 55 divided by the standard deviation is 9. This says less than or equal to, okay? So that's all I have to do for this problem. This one's, I got the easy one on this one, so it'd be 0.133. It says round at least 4 spots, 1333. Okay, just to like write this out real quick. I know y'all have done a bunch of problems, but basically, it comes down to these 2 ones. If you were doing, like the one we just did was less than or equal to. So we said 45 or less. So that means we're shading this way. If you need to draw the picture real quick like this, that helps. So we are going to do, I'll go ahead and write it out. 45 minus 55 divided by 9. And that's all we do in the calculator, okay? If it said, I don't know, 60 or more. 60 or more, or I guess it'd probably say more than 60, but that's fine. If more than 60, okay? That would be, I'm at 60 over here, and I kind of know where to draw it. I didn't put this on my graph. I should have, but my mean is 55, right? So it goes in the middle, okay? So draw the picture, and it does help to see if your answer looks right too. Like this looks like about 13% of that whole thing. So if I was doing this one and I needed to do more than, I'm going to use that same button in the calculator, and it's still going to be set up the same way. I would do 60 minus 55 divided by 9. The problem with this is that I have less than or equal to and I want more than, okay? The way I do this is what this is finding right here is it's finding everything to the left of this. So I know that this adds up to be 100% because 100% of the data is under the curve. So what I want to do here is to flip this sign, I'm going to put a 1 minus in front of this, and this is what I would put in the calculator. So again, what this part finds is actually to the left of this. So if I do 100% or 1 minus that decimal, it'll flip it and give me the other side. So anytime you need to flip the sign, you put a 1 minus in front of there. All right, this one is a sampling distribution. So the sampling distribution for the mean stays the same. So my mean is 1.13, so it stays the same. And then the standard deviation, what you're going to do is you take the standard deviation divided by the square root of n. N is the sample mean of 8. What this is saying is you are sampling 8 people, and I'm going to look at the average of those 8 people, okay? So anytime you sample more than one, like that previous problem, we said, what's the probability you randomly select one person that's 45 or less? This one, we're going to randomly sample 8 people and look at the average of those 8 people and compare it to the average. So the average, the mean of X bar, it stays the same, but the standard deviation you're going to change by this formula right here, the standard deviation divided by the square root of n, and n is how many you're sampling. So that would be 0.20, I don't know how many I'm supposed to round to, 2 decimal places, so 21. All right, so I'm guessing this next problem is going to have something to do with this. So this is very similar to number 7. It's kind of combining number 7 and number 8. So what's the probability that a sample of 35 exams will have a mean score of 530 or more? Okay, so what I'm going to do is I can do the same formula that we've been doing, the mean minus the data value minus the mean divided by the standard deviation. So I'm looking at 530 minus the mean, which is 510, divided by my standard deviation. Okay, so since I am sampling 35, my standard deviation is going to change. My original standard deviation is 180, but now I need to divide that by the square root of n, which we're sampling 35 exams. Okay, so if we sample more than one, you change your standard deviation, which the test is going to be in the same order. So just know when you get to number 8, like you do that problem, the next problem is going to follow that, where you got to do that divided by the square root of n at the end. Okay, now where are we at? So this is 530 or more. So just like that example that I just drew out, I can't flip that sign in the Alex calculator. So the way I flip it is I'm going to put a 1 minus in front. Since I want more, and the sign they give me is less than or equal to, I put 1 minus out in front. So this would be 0.255. 55. Okay, so just to undo this real quick, so like if I found this, that's saying it would be 75%, basically 75% to the left, so that'd be 75% is less than 530. So that is where I do the 1 minus, and it's actually 25% is more than, okay? So anytime you need to flip this sign, you put a 1 minus in front, and that will change that to greater than. Very similar to this one. So the mean, I guess this formula is a little different. This is a sampling distribution of a proportion. So instead of talking about a mean and standard deviation, you're talking about a percentage. So my percentage is still based on the original one. The formula for this one is the square root. I'm going to hit the division sign to get a fraction. I do 0.76. Now what the book's going to say, or what you've seen in Alex, is 1 minus 0.76. But all this is like what percentage said yes and what percentage said no. So 100% minus 76% is just 24%. You can definitely write it like that, but you could do 0.76 times 0.24. If you can do that in your head, that's nice, but you don't have to. And then I divide by how many I'm sampling. I am sampling a random sample of 8. Okay. So this one is P times 1 minus P divided by n and the square root of that. So I press enter, and I get 0.151. It'd be 1.5 because I think I'm only supposed to do 2 decimal places, but that's fine. All right, so confidence interval. This one you click take a sample, and it takes a sample for us, and we're going to get most of our numbers from that. So this is 45. Our point estimate is our sample mean, 5.47. Population standard deviation, make sure you choose the right one, the one on the right here, 2.42. Critical value is the hard piece right here. I'll draw a picture real quick to help you out. This one is 90%, right? So what this is saying is you have 90% of this normal curve shaded, okay? And this question is asking what z-score goes along with that. Well, if there's 90% on the inside, that means there's 10% on the outside, right? 100% minus 90% would be 10%. So that means there's 5% on each side. Okay, this tells me that I want to use the one that's 0.05. So that's all you have to do. The formula that I tell students is 1 minus the confidence level divided by 2. So again, 100% minus 90% tells you what's on the outside. There's 10% on the outside, but then I got to divide it by 2 because you got some on the left side and some on the right side. So all this does is tell me which number on this chart right here to use for my confidence interval. So 1.645 is the one that I'm using. Once you get that, it's pretty easy from here. I am going to do my confidence interval 5.47. I'm going to use that plus or minus button again, 0.59. Press equals. So my confidence interval is 4.88 to 6.06. But the manufacturer claims that it's 5.74. Which is, so that red dot is in my interval, so we're good. We do not contradict the interval, or contradict the claim because we are inside the interval, okay? Your answer is always A or D on this one. It said, no, we don't contradict because it's inside, or yes, it does contradict because it's on the outside. So it's either A or D always on this one. But this one is inside, so it does not contradict. Another sample size one. This one has same kind of idea here. Sample size is 32. My point estimate is 4.81. My population standard deviation is 1.92. Critical value, again, if I need to find this, I got 99% on the inside. So 1 minus 0.99. I got 99% on the inside, so I got 1% on the outside. And divide it by 2 means I got 0.5% on the inside or the right side and 0.5% on the left side. Okay, so again, just to see that formula all in one spot, 1 minus the confidence level divided by 2, and that will tell you which one of these to use. So I'm going to use that top one, the 0.005. It is 2.576. All right, so now I got to find my confidence interval. I do 4.81 plus or minus 0.88. And I get 3.93 and 5.69. Okay. And then they're claiming right there, the text right there above it for the point, the red point, they're claiming 5.42. So once again, it does not contradict because it is inside the 99% confidence interval. Another one. So on this one's talking about proportions. So my sample size here, we sampled a random sample of 65. That's up here at the top. You can always add up 26 and 39 too. But we sampled 65 scratchers. Our point estimate is we're trying to figure out the winning one. So they win at 40%. Our critical value, same thing that we just did. 95% on the inside. So that's 5% on the outside. And then we divide it by 2. Because there's 2.5% on the right side and 2.5% on the left side. That tells me which of these critical values to use. So I'm using 1.96. So 0.4 plus or minus 0.12 equals 0.28 and 0.52. So we are 95% confident that The Scratchers is somewhere between 28% and 52% winners, but they claim it's 56%, okay? So here I'm on the outside, so yes, it does contradict because it is on the outside. So we're 95% confident that you win 28 to 52% of the time, but they're saying it's 56, so yeah, we got a contradiction. Next one is hypothesis testing. I bet all the rest of them are kind of hypothesis testing. The null hypothesis is always equal to whatever number you're arguing about. We are arguing about 84. It says higher than 84, okay? This is where you get the information for these part right here. So it says higher than 84. So we do the mean is greater than 84 since I'm looking for higher than, okay? This is going to be a one-tailed test because I only want the higher side. The critical value tells you how to do it right here in this sentence right here, okay? To the right side. So all I got to do is hit this button in the calculator, the Z box button. It kind of looks just like that. I put 0.085 in. I want the right side. I know this is the right side because it's positive. Okay? So make sure everything matches up. Like if you were to get a negative or whatever, that makes sense. Like that blue area looks about like 5% of the whole thing. So just kind of check your numbers to make sure you did it right. The test statistic, they give me the formula right there. It's X bar, which is my sample. We did a random sample 68. The mean was 87.5 minus the number we're arguing about, which is 84. This should look very familiar because this is just the Z-score formula that we were using earlier, divided by the standard deviation. Oh, by the way, if you forget the Z-score on the test, you can just go to this problem and find it because it's given to you right there. Divided by the square root of n. How many people we sampled? 68. Okay, so X bar minus the mean divided by the standard deviation divided by the square root of how many people we sampled. So it is 2.018. All right, so we see that it put the 2.018 is in my blue region. That is called my rejection region. So it says it lies in the rejection region. So the null hypothesis is rejected. So if it lands in the blue region, it is rejected. I believe on this one, and the answer is only A or D as well, because this one says it doesn't lie in the rejection region, so it is not rejected. Okay, so if it lies in the rejection region, it is rejected. If it doesn't, it's not. Next one has to do with proportions. What proportion are we arguing about here? Work for a great place is not 91%. Okay, so we are going to do... Oh, I always get mixed up for it was P or P hat. I think it's P. Okay, sorry. P is 0.91, and then it says is not 91%. So we're going to do P is not equal to 0.91. Okay. For part B, you got to test to see if you actually can do this test. Basically, this is just checking to make sure your percentages aren't way off and you're asking enough people. So we do 0.91 times the amount of people we surveyed, which was 220. I did that backwards, but 220, the amount of people we surveyed, times 0.91 is 200.2. And then the second one, again, is all that's saying is 220 people we surveyed times 1 minus P. That's saying if 91% said it is not a great, or is a great place to work, 9% said it's not. Okay, so that's, you're just doing the times the people that said yes, times the people that said no. So this is 19.8. We are good if these numbers are above 10. It says that right here, so you don't have to memorize that. Okay. Oh, look, here is that formula too. So I was going to give you all formulas, but here's the trick, and I'll see how many of y'all listen to my video. If you look at number 14, it gives you the Z-score formula. If you look at number 15, it gives you the other Z-score formula. So they are given to you on the test. You just got to know where to find them. All right, so this is a two-tailed test because it says not equal to. So since it says not equal to, it could be lower than or it could be higher than. So this is a two-tailed test. And what we're going to do here is the same thing in the calculator, that Z 0.05 to find my critical value. And this one only gives me the positive. Okay, but this whole thing is symmetric. So it is fine if I put the negative. Oh man, I keep forgetting to put the negative there. Negative, come on, -1. So I have the negative and I have the positive, okay? Since it is not equal to, it's a two-tail because it could be less than or it could be greater than. So now we got our chart. We got to find our test statistic. We've done this formula once, but this is going to be, this is a little harder because they don't give us all the numbers right there off the bat, but I'll show you how to do it. I'm actually going to hit the division symbol twice. So we surveyed 190 said yes out of 220. That's my sample statistic. And then I'm seeing if it's 91 or not, how far it is from 91. Now I do the square root. Now I'm going to hit the division symbol right there. So my standard deviation for this one is 0.91 times, we can do 1 minus 0.91 divided by n. We sampled 220 people. So again, let me look at this formula. The 190 divided by 220 is going to be our X bar, basically. Like how many we sampled that said yes. Minus what the company's saying, they said 91%. And then we divide by the standard deviation. This is the formula that you would use on number, I mean, I don't remember what number it was, like 8 or 9. The P times 1 minus P divided by N, okay? So again, those formulas that I was trying to figure out how to give you are right here for you on these problems right here. So go to number 14 and 15 and you can find the formulas that you need, okay? All right, so this is my test statistic. It is negative 2.42402, I guess, 403. Oh, it's negative. Why is my iPad not putting negatives in there? Okay, so now I find that it is in my rejection region. So just, I think it's A. It lies in the rejection region, so it is rejected. So there is evidence to support that it's actually not going to be 91. The way I remember this is the knots. So it is in the rejection region, is rejected. There is evidence. On this one down here, the D, it does not lie in the rejection region. Oh, I highlighted the wrong word there. Does not lie in the rejection region, so it's not rejected, so there is not enough evidence. Okay. 16. Doing the mean one. These ones are a little easier. I think this problem's a little harder, though. All right, so we're arguing about whether it's more than 13.1. So I do the mean is equal to 13.1. That H sub 0, the null hypothesis, is always going to be equal. And then I do more than 13.1. So I do 13.1 right here. Doing greater than because it's more than. Then I come down here. The degrees of freedom is always one less than the number you sample. So to test his claim, he chooses 17. So we do 16. It's more than, so I just want the right side. And then my test statistic, they give us the formula right there for us. It is X bar. What was our X bar? Our X bar is the sample mean of 13.7 minus 13.1 divided by the standard deviation, which was 1.4 divided by the square root of how many people we asked, which was 17. Okay, so that's, I know it says T equals, but it's very similar to the Z-score. You just use T when you sample less than 30 people, but everything kind of works the same way. So I press equals and I get 1.767, and you don't have to know that less than 30 people because it tells you to use the T-test. So now I pick which side I'm shading. I'm shading right there. And then I find my p-value. To find my p-value, I'm going to use this button right here with the T. And it says greater than. Okay, so I type in my test statistic, 1.767. My degrees of freedom is 16. And it's greater than, T is greater than. We want more than, so we don't have to do 1 minus. We're not trying to flip that. We just press equals, 0.048. But again, if you wanted less than on that one, you would have to flip it, okay? So the sign in the calculator defaults to greater than, so if you want to flip it, you put 1 minus in front. All right, so now to compare this, we look at the p-value and the level of significance. I'll put it in the calculator so you can see it, 0.05, and then the other number we're looking at is, I'll just put some dots here, 0.04. So 0.05 is greater than 0.04. When the p-value is less than the level of significance, you reject. So this one is you do not reject. The p-value is greater, so you do not reject. There is not enough evidence to support the claim. So again, when the p-value is less than, oh wait, I did that backwards. I put it in backwards. 0.04, my p-value, that's why I hesitated there for a second. When the p-value is less than alpha, sorry, we got to switch it to this one. P-value is less than alpha. The alpha is 0.05, so 0.04 is less than 0.05. The null hypothesis is rejected, so there is enough evidence to support the claim. So if the p-value is less than alpha, you reject. The p-value is greater than alpha, you do not reject. All right, two more. 17, very similar to what we were just doing, but you got proportions this time, so a little bit tougher one. So we're going to do p. It says less than 83, so 0.83. Oh, this one's always equal. And then p is less than 0.83. We got to do our test again. How many people we surveying? 140 people times 0.83. is 116.2, and then 140 people times 1 minus 0.83. So again, this is just testing to make sure that you're not testing something crazy and you're asking enough people. All right, so this is a less than test, so it's going to be one tail. Now we got to do that test statistic. I always hit the division bar twice because I got to do 106. Say they recommend out of 140, 140, and then minus the 0.83, okay? So our sample minus the number we're arguing about divided by the square root of 0.83 times 1 minus 0.83 divided by n, which is 140. All right, so that's my test statistic. So I get negative 2.295. Shade the right side because we want more than the p-value. So to find the p-value on this one, we are using the z. So yeah, we use that button right here. We put in our test statistic, but we want the greater than. We want to flip that sign. So this is where we're going to do 1 minus. So I do 1 minus on that, and I get 0.011. All right, so again, now we got to compare these. My p-value compared to my level of significance. The p-value is again less than, so when the p-value is less than, the null hypothesis is rejected, and there is evidence to support that it's different than what they say. There's evidence to support. Oh man, it was less than. Oh man. I keep messing up. I'm trying to hurry up and finish because I got class in just a second, and I keep messing those up. Okay, sorry. My p-value is less than, so I just put that 2.295. It's less than, so I do not. I shaded. Oh, that's where I messed up. Sorry, I'm going to double check. No, we did that right. Oh, that I see where I messed up because that's negative. And when I've been putting my iPad calculator in, it's not putting the negatives in. There. So my test statistic is negative. That would make more sense. So now I'm less than. Okay, now we're going. So now I want negative 2.295. Okay, equals. So this is why I offer. Yeah, nothing's going to change here because it's just the other side. But let's make sure we get our picture right. My iPad's not typing the negatives for some reason. Okay, so everything's still the same. 0.011 is still less than 0.05. So p-value is less than alpha, so you reject. So there is no answer. So again, all I did wrong there was I didn't get the negative on my test statistics. So tell me if you miss something like that on your test and you get almost all the points back because you did everything right. You just forgot a negative. And then the last one has to do with chi-square. Of course, I got a hard one to do, but I want to use the chi-square button right here. This only gives me the greater than side. So I'm going to do 10. I got to think about my picture here for a second because this is opposite of the Z. So my picture here is like this. I know it doesn't look exactly like that, but 10 and 27. I want to find the middle, right? So this calculator gives me the greater than. So if I find 10 to the left, 10 to the right, 10 to the right, and then I subtract, I can use different colors here, and then I subtract 27 to the right, that would give me the middle of those. So I need to do the 10 minus the 27. All right, so I'm going to do 10. My degrees of freedom is 20. And then I'm going to subtract the other one, 27, and degrees of freedom is 20. So draw your little picture like that to make sure you're doing it right and subtracting out what you need to. 33, 0.833. Okay. And then the other one, I click this button right here, and I think it gives it to me 0.1 degrees of freedom is 20. And that one, I get the answer pretty easily on that one, 28.411 or 12. All right. So that is all 18 questions.